This is Bob Capetta from the College of the Florida Keys, and this lesson is on geometric series as opposed to arithmetic series that we studied earlier. So let's start with an example of a geometric series. An example might be 1 plus 2 plus 4 plus 8 plus 16 plus 32. Now what makes this geometric? You'll notice the common difference. To go from 1 to 2 we add 1, 2 to 4 we add 2, 4 to 8 we add 4. So there is no common difference. This is not an arithmetic series, but there is a common ratio. To get from 1 to 2 we multiply by 2. To get from 2 to 4 we multiply by 2. 4 to 8 multiply by 2. 8 to 16 multiply by 2. 16 to 32 multiply by 2. So what does this look like? We have 1, 2, 3, 4, 5, 6 terms in our list. So let's go with the sum as k goes from 1 to 6. Now my first term has got to be 1. So okay, we'll put a 1 in there. Multiplied by the common ratio, and we use the letter r for the ratio. In this case, my common ratio is 2. So it'll be 1 times 2 to what power? Well, it's got to start at 1, so 2 has got to be raised to some power so that the result is just 1 times 1. And what it'll be is 2 to the k minus 1. And I want to convince you that that's correct. So if I have k and I have 1 times 2 to the k minus 1, if k is 1, we get 1 times 2 to the 1 minus 1, which is 1 times 2 to the 0, which is 1. If k is 2, we get 1 times 2 to the 2 minus 1, which is 1 times 2 to the first, which is 2. And if k is 3, we get 1 times 2 to the 3 minus 1, which is 1 times 2 to the second, which is 4, so you can see the process. But in general, what do we have for the first n terms? So the first n terms, which I will call S sub n, the first n terms of a geometric series will be what? Will be a sub 1, that's our first term, plus, we multiply by the common ratio, a sub 1 times r, plus a sub 1 times r squared times what? Now it's not a sub 1 r to the n, because that would be n plus 1 term. I've got to start at this value and n, so I have n in my list. So if I end at the nth term, that will be what? That will be plus r to the n minus 1. So the sum of the first n terms is the sum as k goes from 1 to n. My first term is a sub 1 times the common ratio, which will be what? Which will be r to the k minus 1. So that's the general form for the nth term of a geometric series. Now, we can certainly add our 1 plus 2 plus 4 plus 8 plus 16 plus 32. That's not difficult for us to do. So 1 plus 2 plus 4 plus 8 plus 16 plus 32, which is the same as we showed on the previous slide, the sum as k goes from 1 to 6 of 1 times 2 to the k minus 1. Well, we just grab a calculator and we add them up, and we get 1 plus 2 plus 4 plus 8 plus 16 plus 32, and we get 63. But what if instead I want the sum as k goes from 1 to 40 of 1 times 2 to the k minus 1? Which would be 1 plus 2 plus 4 plus 8 plus dot 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 in my last term. If I plug in 44k, 1 times 2 to the 40 minus 1, 2 to the 39th power. So can we make some sense out of this? Can we make some sense out of adding up all of those terms? So the sum of the first 40 terms, which I'm going to call S, is going to equal that 1 plus 2 plus 4 plus dot 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 plus 2 to the 39th. And to figure out what S is, I'm going to multiply both sides by the common ratio. So what would 2S be? Well, 2 times 1 is 2. 2 times 2 is 4. The one before 2 to the 39th is 2 to the 38th. If I multiply 2 to the 38th times 2, that'll give me 2 to the 39th. And if I multiply 2 to the 39th times 2, I get 2 to the 40th. Now, what we're going to do is we're going to subtract. So we're going to say 2S minus S equals this whole number minus that whole number. So 2 plus 4 plus 8 plus dot 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 plus 2 to the 39th plus 2 to the 40th minus what? Minus 1 plus 2 plus 4 plus dot 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 plus 2 to the 39th. Well, then what do we get? What do we get? We get 2S minus S, which is S. And then you'll notice 2 minus 2 goes away. 4 minus 4 goes away. 8 minus 8 goes away. 2 to the 39th minus 2 to the 39th goes away. And what am I left with? The only thing upstairs that didn't subtract out is 2 to the 40th. And the only thing downstairs that didn't get subtracted out was 1. So my answer is 2 to the 40th minus 1, which is a very large number, of course. Something times 10 to the 12th power. So approximately 1.0995 times 10 to the 12th power. So the minus 1 isn't making a whole lot of difference. But that's the process that we use to find the sum of the first n terms in a geometric series. Let's do one that's a little bit simpler than that, and I will show you how that technique can actually help us do it. So let us take a look at 4 plus 4/3 plus 4/9 plus 4/27 plus 4/81 plus 4/243s. So we have a common ratio. To get from 4 to 4/3, we multiply by 1/3. To get from 4/3 to 4/9, we multiply by 1/3. To get from 4/9 to 4/27, we multiply by 1/3. To get from 4/27 to 1/81, we multiply by 1/3. To get from 4/81 to 4/243s, we multiply by 1/3. Now we have 6 terms again, so I'd like to express this in a k fashion. So this will be the sum as k goes from 1 to 6. My first term is 4 times my common ratio is 1/3, but it's got to start out at 1/3 to the 0 power. It's got to end at 1/3 to the 5th power. So that's 1/3 to the k minus 1. So that's a way for us to express that in sigma notation. Now, it might be nice for us to figure out what that sum is. Can we determine what the sum of those 6 numbers are? Well, let's take a look. And we could certainly use our calculator to get there, but I want to demonstrate the process of multiplying both sides by 1/3. So this is what we have for S. The common ratio in this case, common ratio is 1/3. So let's multiply both sides by 1/3. So 1/3 of S is 1/3 of 4, which is 4/3. 1/3 of 4/3 is 4/9. 1/3 of 4/9 is 4/27. 1/3 of 4/27 is 4/81. 1/3 of 4/81 is 4/243. Plus 1/3 of 4/243 gives me 4/729. So we see our process. So can we subtract these one direction or the other to see which way it's going to go? I could take S minus 1/3 S, or I could take 1/3 S minus S. I think I'll stick with s minus a third s here just to kind of show how this process is going to work. What is s minus 1/3 of s? So this minus this would go away, this would go away, this would go away, this would go away, this would go away. And what am I left with? I am left with 4 subtract 4 over 729. Which gives me what? Gives me an answer of 2912 over 729. And we could check that by adding all those together to see how close we get. So let's kind of generalize that. So we've seen how we can add the first 6 terms that way. So let's take a look at our general form for a geometric series and see if we can generate a rule for the sum of the first n terms. So what do we say about that? A generic geometric series would be a1 plus a1r plus a1r squared plus a1r cubed, if I go to the nth term, plus a1r to the n minus 1. N terms, a1r to the 0, it starts at r to the 0, ends at r to the n minus 1, so there are n terms there. So what I get is I get the sum as k goes from 1 to n of a sub 1 r to the k minus 1. So that's a little tricky in terms of how we make that work. But that's how we can look at that series. Now, what is the nth term? The sum of the n terms we have up there, a1 plus a1r plus a1r squared plus a1r cubed plus dot 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 plus a1r to the n minus 1. What I'm going to do is I'm going to multiply both sides by the common ratio r. So what is r times s sub n? That's a1 times r plus a1 times r squared plus a1 times r cubed plus dot 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 plus a1 times r to the n minus 1 plus a1 r to the n. The last term would be a1 r to the n. Now if I subtract them, if I take s sub n minus rs sub n, what goes away? I wind up with a sub 1 minus a sub 1 r sub n, the things that do not subtract out. So factoring out the s sub n, we get 1 minus r. Factoring out the a sub 1 over here, we get a sub 1 times 1 minus r to the n. Divide both sides by 1 minus r. A sub 1, 1 minus r to the n over 1 minus r. So that is the sum of the first n terms in a geometric series. That's a nice formula to look at. But oftentimes, rather than using the formula, it's just easier to write out something like this and then do the subtraction that way. I think that's a safer way to go. But let's go ahead and take a look at infinite geometric series, because that is certainly a topic that you will use when you move to calculus. So infinite geometric series. So our favorite one like that would be 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus forever. And all that is we can think of it this way, the sum as k goes from 1 to infinity of 1/2 to the k this time. 1/2 to the first, 1/2 to the second, 1/2 to the third, 1/2 to the fourth, 1/2 to the fifth. Or you could say the sum, our starting term, is 1/2. Our common ratio is 1/2 to the k minus 1 as k goes from 1 to infinity, fitting our previous model. But you can see the advantages of looking at it that way. Well, here's our rule. if the absolute value of the common ratio is less than 1, then the infinite sum which I'll call S infinity, is simply the first term divided by 1 minus the ratio. So in our example here, what do we see? Our first term is 1/2, and our common ratio is 1/2. So our S infinity will be 1/2 over 1 minus 1/2, or 1/2 over 1/2, which is 1. So let's take a look at another one. This time I want my first term to be 6, and I want my common ratio to be negative 1/3. So what would S infinity be? It would be 6. A third times 6 is 2, but it's negative 2. Negative 2 times negative 1/3 is positive 2/3. Positive 2/3 times negative 1/3 is negative 2/9. Negative 2/9 times negative 1/3 is positive 2/27. And that goes forever. So we have an infinite sum, we have an infinite geometric series here. Now I could call that S infinity, and then I am interested in knowing what that's going to be. So what am I going to do? I'm going to go ahead and take a look at what is negative 1/3 of S infinity. Negative 1/3 is 6 is negative 2, so you'll see everything has just been shifted. Plus 2/3 minus 2/9 plus 27 ... So that if I subtract them, S infinity minus negative 1/3 of S infinity, everything's gone except the 6. S infinity minus negative 1/3 of S infinity is S infinity plus 1/3 of S infinity equals 6. That's 1 S infinity plus 1/3 of S infinity, which is 4/3 of S infinity equals 6. So S infinity is 6 times 3/4, which is 18/4, or 9/2. Now I did not use the rule that I gave you on the previous page. I wanted to go ahead and do that using analysis, and we did that. We were able to go ahead and get our 9/2, but remember, I said that the formula, the quick formula, is S infinity is first over 1 minus the ratio. S infinity is the first term over 1 minus the common ratio. So S infinity is what? What's my first term here? 6. 1 minus the common ratio, 1 minus negative 1/3. S infinity is 6. 1 plus 1/3, 6 over 4/3, which of course is 6 divided by 4/3, 6 times 3/4, which is 9/2. So that's a nice strategy to use. Let me quickly do one more in that bend, just using the quick formula this time. So if I want to go ahead and do 7 plus 7/2 plus 7/4 plus 7/8 plus ... which we will write how? We will write as the sum of 7. K goes from 1 to infinity. Common ratio is 1/2 to the k minus 1, because again it's got to start at 0, 1/2 to the 0. And this will be the first term over 1 minus the ratio. First term is 7 over 1 minus 1/2, which is 7 divided by 1/2, which is 14. And that will conclude this lesson.